Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Izzah Nadira binti Ruzlan, metric number DE200104. So basically, today I would like to present about transfer circuit. Okay, so next to the next part. Um, for introduction, for series calculation using the input of this RLC circuit will be made and the result will show what happens. We must establish voltage, current and power using the Fourier method. The summation of each computation loop can be found by using the loads parameters at the correct values. Combination all the capacity result in the summation. So basically for this project, the RLC circuit was calculated using the Fourier series calculation technique. In a Fourier series, a periodic function is represented by the sum of the sine and cosine function. For non-periodic function, the Fourier transform is employed instead of the Fourier series. A representation that separates a periodic function into two pieces is called a Fourier series. It has two parts, a DC component and AC component, made up of an unlimited number of harmonic sinusoid. To calculate the typical power absorbed by a circuit as a result of periodic excitation, a power calculation should then be done. The average powers in each harmonical ring, voltage and current are added to create the total average of power. Okay. Next, for the result and analysis, so here's is our circuit. So for any mesh model where the input is a non-sinusoidal AC signal, we stand for Fourier series calculation for Fourier transform application. Each group shall compute, simulate, and create a comprehensive electrical network consisting of resistance, capacitance, and inductance, which is RLC. Your lecturer should give his or her approval for each suggested circuit. So by using this circuit requirement as a guide, we can say that the circuit we selected was approved because it met all the criteria.
Assalamualaikum and salam sejahtera. My name is Ahmad Adam Alfisal, matrix number CE210224. Today I'll be presenting the manual calculation for question A. So in the circuit, there consists of the resistor 40 ohm and the independent current source, which is 5 exponent negative t, and the capacitor is 20 microfarad. So to find VR, we have to convert everything to frequency domain. So 20 microfarad equals to 50 over omega, and the current equals to 5 over plus 1 omega, and 40 ohm equals to 40. So we are going to use using voltage divider rule, which is over here. And then we put in all the values into the formula. And then this is the results that I have concluded. That's all for question A. Thank you. So for the manual calculation for question B is similar, but then it changed the value to the current value to 15 exponent negative t. So everything is the same. The values of the capacitor, the resistor, which is 50 over omega, and then 40, and over here the current equals to 51 plus omega, and we've used the voltage divider formula over here, and this is the results that I have concluded. That's all for the manual calculation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Nabila Edu with metric number DE20081. So I will be proceed and continue for the simulation result. As you can see, this is the circuit simulation for our question that has been simulated using MATLAB. So for this simulation, we didn't use the Simulink section in MATLAB yet. We are using the Simscape in MATLAB. For the AC current supply, we put the constant current value at 5 exponent 1 over 2. This is because in the equation it has been stated 5 exponent negative t, yet in the MATLAB we cannot use the t unknown in the parameter. So we predict and manually estimate the t by using the MATLAB SimScape. We have been discussed to put the t value as 1/2. The result and the value that we have gotten by using the t equals to 1/2 are quite similar with the manual calculation that we have been calculated. This is the circuit and the result for A equation, which the equation asks to find the voltage output for the 5 exponent negative t input. So when we define the t as 1/2, so the V out, we got it as 1000. So this is the graph for the V out in the capacitor load. Okay, then for the DC current supply value for B, which the question has been asked, what will happen to the voltage output when the input supply change to 50 exponent negative t. Since we have defined t as 1/2, so we just put the 50 exponent 1/2 in the constant current parameter, and the result would be like this. It's actually close to 10,000, so it will properly round off to 10,000. These results are very similar and almost close to manual calculation that we have been calculated. Lastly, this is the graph for the voltage output in the capacitor. Discussion for this project is we have calculated the value by using the manual calculation, and we have been simulated the circuit as well, and we got the similar value which is close to the manual calculation. So we can assume that these both equations are tally and are correct. During the process of doing this simulation, we have to define the t value, because in MATLAB we couldn't, as I have mentioned before, in MATLAB we couldn't put the t in it, so we have to define what value to put, what the value of t to put in the simulation to get the correct, which the value will be close to manual calculation. In order to do that steps, we have been predict and manually try and error the t value in the simulation circuit, and look at the result if it is close to manual calculation or not. There's a very basic discussion that I can describe in this project. Okay, that's all from me for this question. Hopefully all of the things have been cleared. Thank you for hearing.
Okay, lastly for the conclusion, finally the development of a model network with DC current supply, resistance and capacitance has been selected as the RLC circuit. There are numerous ways to calculate the RLC circuit, including the Fourier series, Kirchhoff current law, Kirchhoff voltage law, mesh analysis, nodal analysis, and many others. This method can be used to calculate the RLC circuit in a conventional way or in a complex way that refer to the complex theorem. A certain method must be used to correctly complete the computation in order to obtain the result. If this research has been used, the Fourier series method, the input signal from the circuit must be stated in the Fourier coefficient, also known as the Fourier expansion, in order for the Fourier series computation and simulation to start. Yet, for the primary manual calculation already has instruction on how to do the calculation that transform the input signal into the Fourier expansion, but since the question given the current supply in exponent, it is impossible to apply Fourier series for this question. That's all from me. Thank you.